Hello friends. Welcome to my YouTube channel. CPP Operation. Steam Drum. Introduction. The steam drum is a critical pressure vessel in a water tube boiler, acting as the heart of the steam water circulation loop. In high-pressure applications, its primary role is to ensure the reliable delivery of high-quality, dry steam while maintaining stable boiler operation. Primary functions. Steam water separation. The drum acts as a gravity-based and mechanical separator. It receives the steam water mixture from the furnace riser tubes and separates the steam from the water. This ensures only high-quality, dry, saturated steam enters the superheater, protecting downstream equipment from moisture-induced erosion. Water reservoir and circulation head. It stores a reserve of water, providing the necessary hydrostatic head to drive the natural circulation of water through the downcomers and into the lower furnace headers. Buffer for load changes. The drum volume provides a vital buffer during fluctuations in steam demand. It accommodates the swell, sudden increase in volume, and shrink, sudden decrease, of the water level that occurs when boiler load changes rapidly. Water quality control. It is the primary station for maintaining boiler water chemistry. Feed water distribution. Incoming feed water is introduced into the drum, often through internal piping, to mix with the concentrated boiler water. Chemical treatment. Chemicals are injected here to prevent scale formation and control internal corrosion. Blowdown. A portion of the concentrated water is removed, blowdown, to manage the level of dissolved solids, preventing carryover and scaling. Drum internals. The interior of a high-pressure steam drum is highly engineered to facilitate phase separation, which contains some internal fittings and arrangements as described. Feed water distributor. This is a header connected to the feed water pipeline from the economizer. This header runs lengthwise in a drum. This is perforated so that the water can be distributed evenly in the drum, to minimizing thermal shock and localized cooling. Surface blowdown header. This is a header connected to the drum blowdown pipe. Blowdown is given to maintain the impurity level of the boiler water. This header is normally placed just below the working water level of the drum. This header is also perforated so that the blowdown water can be collected evenly from the drum. Chemical dosing header. The pipeline from dosing pump is connected to a header fitted inside the drum. It also runs throughout the length of the drum, and is perforated, so that the chemical can be evenly distributed in the drum. Anti-vortex spider. It located at the inlet of the downcomers. It is a crucial metal grating or cruciform-shaped device, located at the inlet of the downcomer pipes inside a boiler steam drum. Its primary function is to prevent swirling or vortex formation, as water drains from the drum into the downcomers. Steam separators and purifiers. Different methods of steam separation are used in the boiler drum. Among them, following methods are commonly used. By changing the direction of flow. In this method, the steam direction is changed many times intentionally before leaving the drum. The heavy water particles cannot change direction so quickly as compared to the dry steam. So, they fall back in the shape of water droplets. By using baffles, steam and water mixture is allowed to impact on baffle plates placed the moist steam path. Heavier water particles lose its kinetic energy and fall back. Only dry steam enters into the steam space. Primary separators. Also known as cyclone separators. These use centrifugal force to throw heavier water droplets against the walls, while allowing steam to rise to the center. The primary stage is formed by the two concentric cones and spinner blade or spider blade. The fixed spinner blades impact a centrifugal motion to the mixture of steam and water flowing upwards through the inner can. Heavier particles come down and steam go up. Secondary separators. Often located in the upper section, these provide a tortuous path for steam to force out any remaining fine water droplets before the steam exits. The secondary stage consists of two opposite banks of closely spaced thin corrugated sheet or wire mesh. It directs the steam through a curved path and separates the remaining water. Since the velocity is relatively low, this water is not picked again, and flow down to the drum water. This stage is also called steam scrubbing. Screen dryer, also known as demister pads. This is the third and final stage of steam water separation. It removes the residual moisture from the steam leaving turbo separator. The screen dryer box consists of wire mesh of different levels. Dry steam can easily pass through these screen and water particles carried by steam fell down by gravity. The steam coming out from the dryer is totally moisture-free desaturated steam. External mountings and safety equipment. Safety valves, essential for overpressure protection. High-pressure boilers typically require multiple, self-operating spring-loaded safety valves which discharge certain amount of fluid when drum pressure is exceed the predetermined safe pressure. Level control systems. Drum level transmitters and local gauge glasses monitor the drum level. Because drum level control is essential for safe operation of the boiler. Pressure and temperature instrumentation. Drum pressure and temperature are continuously monitored to ensure the vessel operates within its design limits and to trigger safety interlocks if parameters deviate. Thank you for watching. Please do like and subscribe.